Hello, in this section we will look at parallelism and asynchronicity. The first mistake was overusing threads instead of tasks. If we compare tasks and threads, actually a task is an abstraction over the threading model, though there are many cases where a task doesn't have to be related with a thread at all. A task offers facilities such as timeout, cancellation, or continuation mechanism. You can await tasks. You can nest them. You can pass different options such as stating a task will be a long-running task or a task can be associated with a synchronization context. These abilities does not exist in the threads. A thread only refers to some flow that occupies the CPU core. My suggestion is, unless you need advanced scenarios and exclusive control over the threads, almost never use threads, but stick to tasks wherever it's possible. Also note that, although many times a task is an abstraction over the thread, at a later point, a task can actually encapsulate a different thread. Here, a use case for the tasks. We have a method called printTime, and in a while loop, it actually prints the current time. So in order to use this as a task, we call this via task.run, and it will print the time at each second. Also, the thread that is created by the task is a background thread. That means it won't prevent the process to stop. That's why we need an additional blocking mechanism, such as console.readKey, so that the process doesn't end. Here we see additional ways to create tasks. So, in the first example, we create a result directly from an integer. This way, if your task doesn't involve a thread, you can just return direct results. Notice in this case, the task abstraction is not associated with a thread. Also, in the first example, to create a task from result, we need to allocate a task object. If you are calling your task inside heavy loops, this may allocate unnecessary memory. So, recently, .NET Runtime introduced a value task, that a task object that is allocated in the stack. Finally, a third way to create a task that you can explicitly control when a task ends. So we create a task completion source and then we return as a task. And notice in another task, we specify t.setResult as 4 that signals that task should end. So these are the different ways to create a task. In the next video, we will see not understanding thread safety.